Good morning, everybody. Thank you for joining us today for the 5th Argo Workflows and Events Community Meeting of 2020. What we normally do is we'll have a few demos and maybe we'll typically talk about some new features. And then at the end of the meeting, there's an opportunity for you to table any kind of discussion topics or particular things you'd like to talk about as well. We've got a community doc that I'm sharing on the screen now. So it would be fantastic if we could have anybody who's here add yourself as an attendee today, so we just know who's coming to the meeting. I'll just start a section there for people to add themselves. For those of you who are new to Argo Workflows and Events, just a little bit of background. Argo Workflows is a cloud-native system for executing workflows. It's very popular for machine learning and also kind of popular within some of the CI community as well. And Argo Events is a system for triggering events in your cloud using the cloud event specification. So things, for example, triggering a workflow if a file has appeared in S3. My name's Alex, and I'm the principal engineer working on Argo Workflows. And from our core team today, we've also got Derek, Bala, Jesse, and Mukalika are also joining us as well. Now, if you want to ask any questions during today, you can ask those questions in the Zoom chat, or you can come and ask us in the Slack channel afterwards, or there'll be opportunities during the course of today to just ask questions as we go along. And you can just ask those questions out aloud. If the answer is going to be quite long or it's going to require a follow-up, we'll potentially discuss that with you in Slack. So the first thing for today, this agenda is not in the correct order, but that's fine. Derek has been working on some kind of important changes to Argo events around things such as the gateways, sensors, in a goal to kind of simplify and make it easier to use, as well as a couple of security aspects. And he's going to talk a bit about those today. So Derek, can I hand over to you, please?
Yeah, thank you. My name is Derek. I'm from Intuit. I work on both Argo Workflow and Argo Events. You might have noticed that we have done a series of simplification on Argo Events specs. Let's say you don't need to give a lot of details on the gateway spec and sensor spec and this kind of things. All these things just I want to make it easy to use. Today, I want to give a heads up about what kind of change we're going to do in future. All this change, the purpose is just want to make Argo Events easy to use, a reliable and production level product. Okay, let me share my screen. This document is the proposal about the enhancement for Argo Events. You can get this link from the community documentation. The first part of the I'm gonna quickly go through this proposal. The first part of the proposal is an introduction about the current infrastructure, and then I listed all the problems here, and then I'm gonna skip this part and quickly go to the proposals. If you have time, you can read it and give comments on it. We are hearing your voice. Let me go to the proposal. So first thing we're gonna do is we're gonna merge the gateway object to event source. So right now we have 3 CRDs in Argo Events: gateway, sensor, and event source. And after the simplification of the gateway, and then you'll see that there's almost nothing left in gateway object. So that's the reason you want to merge a gateway to event source, and then later on you only need to give all your events related definitions in event source spec, and then there's no gateway at all. So that's the first thing we want to do. Next next one is, if you look at the current architecture, there are some things not in good design. Let's say so right now, if you run your gateway or your sensor, you need to have a service account with some RBAC settings to make it work. Even your event source is the webhook type event source, which doesn't need to access Kubernetes cluster. You also need the service account for that. A sensor is the same thing. If you only want to trigger HTTP endpoint, you also need a service account to do that. And that service account need to have some permissions to listen to event source, gateway, and sensor. That's inconvenient for the user, and it's not secure. So the second and third thing we're going to do is to rewriting the controller for you merge the event source and the sensor, so that you don't need to have a service account like that to do things, unless you want to listen to some Kubernetes events, something from the Kubernetes itself, and that is something we cannot avoid to create a service account to do that. Okay, so that's the third. That's the second and third thing we want to do. And next one is, since we want to get rid of the gateway object, and then we will make some change on the dependency definition in sensor spec. Right now, in the dependency part of sensor, you need to give the gateway name, event source name, things like that. And then because of the merging, and we don't need to give the gateway name, and that makes more sense. Your sensor only relies on the event source. There's no gateway. And we want to introduce a new CRD named event bus. And this event bus is used to represent a pub subsystem in the backend. So right now for Argo events, if you want your events to get delivered from gateway to the sensor, there are two ways to do it. The first way is do a HTTP post call from gateway to sensor, and the second way is through NAS. But both of these ways are either not secure and not reliable, or it's not easy to use. For HTTP, we don't want to get this kind of thing deployed in production. Let's say do a direct HTTP port from direct HTTP call from gateway to sensor. If there's anything issue with sensor service or networking issue, and then you will lose your message. So we don't want to use that. And for NAS, NAS is a good thing we wanna introduce to product, to the service. But right now, when using NAS, both gateway spec and sensor spec, and we want to introduce a new CRD object, and then you don't need to give this detail, and then you just use it as a, you don't need to know there's a NAS existence in the system, and then we'll get things down. So with the new event bus CRD, and then every time if you want to use Argo events in your namespace, probably you need to give first thing you need to do is you need to give a events bus CRD like this. You give a name default, and then you by default we're gonna use a NAS, and then you give a spec like this. We're gonna bring up a NAS service for you in your namespace. It's namespace separated. So all your messages from the new event source or current gateway, the message will be sent to the NAS automatically, and then your sensor will read the message from the NAS. You also can give a NAS event bus with a preferred configuration. Let's say you already have a NAS service running somewhere, and they want to use the existing NAS service. So we also support that. These are the major changes we want to do in the future, and then we have the proposals document linked in the community doc. And if you have any comments, any suggestions, please read and do that, and we are hearing. Thank you. Any questions?
Derek, is this a breaking change?
We want to we want to make each of change backward compatible for like several releases, and then we deprecate that. Question? All right.
Okay, thank you, Derek, for that. So we're currently still waiting for Vipad to appear. I'm not exactly sure where he's got to, but fortunately we also have Sumit Nagal, who's a performance engineer into it here, and he is going to talk a bit about how they use Argo workflows for site reliability engineering and performance testing. So Sumit, if you're ready, do you want to take it away?
Sure. Thanks a lot, Alex. So before I jump in, just wanted to give a little bit background. We do a reliability engineering for the Intuit, which is providing support for our Intuit Kubernetes service. And as part of that, we have built something which we thought would worthwhile to share with the community. And this specific talk, briefly talk about that. This is just a brush up, but we can go deep dive if the community has the interest. So what it is, we have seen that running the performance test for specifically performance, scale, and longevity require a lot of time, and it cannot be part of your pipeline. That's the first part. We don't have any native Kubernetes support available in that. You have load runner, you have Gatling, you have frontline. There are many things, but there is nothing is available on the Kubernetes space. Most of the tooling what we have seen they are not supporting the container. They are mainly on that your Git or whichever your version control and get that. Attaching that using Argo CD and Jenkins is also one of the challenge we have faced. So what we have used is something called Argo workflow, and workflow has a very niche way how you can orchestrate different kind of sequence, and we use that. One of the other thing why we opted for Argo is that most of the performance tooling or performance infra, they have a good amount of licensing cost. Just to give an example, Frontline will cost yearly 80K for running the license. Now, Argo workflow doesn't cost, it's open source, it's a free. So that's a other thing. And then it can attach to the actual reporting of a specific technology. And it is agnostic with the AWS, and it can support any of the technology like a Gatling, JMeter, and Karate. And the reason that one is important, most of the conventional tool, if you take a load runner, if you take a frontline, they are attached to a technology. Either someone is attached to JMeter, either someone is attached to Scala. So right now we don't have a mechanism, one cohesive way that any specific tool support most of the technology. And performance testing in last decade has changed significantly. Every 2 or 3 years, there is a new technology come. It was prominently dominated by JMeter, and now the Scala has bring the Gatling. You never know tomorrow what will be there. And now if the team or company is spending that much, it would be very, very challenging for them to attach to the same technology to support the real new tech stack. So what we have come up, and this team, because we work very closely with Jesse Bala, initially when we started that, we did a small POC that how we can use Argo workflow for doing performance testing and creating an infrastructure which is scalable, self-service, and Kubernetes native. So what we have actually done is that this is the same way how any service is being deployed. You have a Git code, you build, and you create a container artifact, which is a Docker. Now what we have done is that we have started adding a test code, and we started creating a container out of the test code. Now, once you have that container out of test code, we use Argo workflow YAML and use this specific container and orchestrate through Jenkins file. As part of this setup, we have created for all our cluster, there is a specific namespace we calling as a perf load infra namespace. In that, we have installed Argo workflow and the Argo UI. And we have created one account, which is Argo workflow account, which will go from this namespace and trigger the execution on any of the namespace via Argo CD after Argo CD sync. So now, if you could see that the existing workflow what we have is become so interesting, and it can go and do things what you actually coded. To demonstrate that, we have one scenario, like this is one of the sample pipeline, and we will add this part as one of the lab example, how anyone can use that. So in this lab example, you could see that we are putting some load, and that load is nothing but the input to your actual test container. In that container, we are saying that you wanted to run that for ramp up time, study time, and how the execution time. And then we are passing this base URL, which is that ingress endpoint. And then we run the load test. Once we run the load test, we push the artifact to the S3. And this is important because one of the biggest challenges is that in pod, every pod will generate specific report. So we put all the reports together, and later we aggregate that with the specific technology which we are using, either a Gatling, JMeter, to convert that, and then later we start pushing that to the Jenkins file, which is nothing but your actual report. So here is the report. So you have running your performance test using this infra, and you can get the actual result coming. So to demonstrate this, I have Naveen in my team. He can just run one live execution and can show that how all this live test running, and then how you can do the live dashboarding. Naveen, are you there?
Yes. Okay, I can take the control.
Yeah, please.
Okay. Can you guys see my screen? Can you guys see my screen?
Yes, go ahead.
Okay, sure. So this is the Jenkins file like Sumit was walking through, wherein like we can perform the load testing execution using Argo from the Jenkins pipeline. So I will trigger like one of the tests from here. And I will give the duration as shorter duration so that like during the demo it may complete. So it usually the shortest it will take is like 4 minutes. So I will try to like do one of the 4 minutes test. The first thing is like input for the load test. So the inputs will be like what is the number of pods, which is like what is the number of load generators you want to generate the load. If a single load generator is able to generate like say 1000 TPS, do you want like, if you want say 10,000 TPS, you can give as 10 pods. So in this case, like I'm giving the default as 2. Peak TPS is like how much per pod, like what is the TPS that you want to give or generate the load. And ramp up time is like how much from like 0 to 1 TPS, how much time you want to ramp up. So you can give like 100,000, how much ever like that pod is capable of, that load generator is capable of. Steady state is like once it reached that 1 or 1000 TPS, it will continue at the same state, and then like the execution will start. So for now, for this demo, I'm just giving like 1, 1, and 1. So it should be done sooner. And now that you have seen like this load testing at PFI, which is like we have a namespace called PFI, that's where the execution will start. So this is the namespace where we have the Argo workflow installed. And what we are doing is we are taking the service account, and that service account is being provided from the Jenkins such that it can perform the Argo actions. So in here, like the Argo submit command has started. So this is the place like where these are the two load generators, perf infra hyphen these two, the run test, and the execution has just started. So if you see here, this is the Argo UI, and this Argo UI provides the live real-time data. So what's happening? So currently we have like two load generators, like run test 0 and 1, and we can see the logs of that one. The execution has started, and two of the load generators will be giving the load for that particular application endpoint. In this use case, like we're doing a CRUD operation of a simple like read and create.
Naveen, can you show
So,
that the Argo workflow file? I think that would be interesting.
yes. So while the execution is in progress, so I will show the Argo workflow file. So this is our like Jenkins file load, which is actually performing the Jenkins actions. And this is the workflow file, which is being called. And in the workflow file, like we have like 5 steps, but like I will talk about the PDB create and delete at the end. But these 3 are the main steps. So run test is the one, as you have seen, like we are giving like 2 pods, and the 2 pods will be generating the load. So the 2 is a dynamic, so you can give 2 or 10 or 100, whatever number. So depends on the load that you want. So it is like highly scalable. List test, so after the run test, like all the execution and everything is done in the individual pods, and they will generate the reports in each of those pods. So list test is the step wherein like once the results has been generated from the individual pods, we will be merging the results. That is where the list test comes. So if you have executed on 2 pods, on the 2 pods results, we are like merging it. And then after the merge is done, we are uploading it to the S3. So after these all 3 steps are done, the next step would be, since the results are in the S3, so we are downloading those assets from S3 here. So downloading the assets from S3, and once the results are downloaded from S3, so we are archiving the results such that the teams can access it from the same Jenkins file. Going back here, and so we have added the PDB create and PDB delete. So this actually enables us to increase the efficiency of the pods that is in progress. If the pod disruption budget is there, the pods will not get killed when the execution is in progress. So that's about the workflow
Naveen,
file.
can we go and see that is the test done? Let's see that.
I think it's almost 36%.
Yeah. So one of the most important thing which we have actually solved that is the cost. Today, running the performance test with any sophisticated tool require 2 things: licensing cost and the operating cost, where you put this controller or load generator or whatever you call it. In last 6 to 8 months, we are running for our platform the TPS up to 30,000 TPS in this infra, and we are costing less than $500 a month on this infra, which is a significant saving in terms of teams who really wanted to save the cost on the performance test. On
So in this example that I'm sharing is 10,000 TPS.
Yeah, even yesterday we have done the 10,000 TPS. And it is a scalable. We are using all the goodies of Argo workflow, and we are using Kubernetes to scale up and scale down. And this is something which we think worthwhile sharing. Naveen, if you can just see that, I wanted to show 1 or 2 more things on this before.
Yeah, this is done. So okay. I think it will be done sooner. So it's merging the results now.
Cool. So one of the other thing which we are working and we are enhancing in this itself is that, can we get this performance test and the chaos to be added? And that would be probably maybe a next meetup we will share. But what eventually will happen is that as everything has been a Kubernetes native, we can run the performance test as well as we can run the chaos test same. And then we can see the chaos interruption, and then we can measure the performance. This is a good segue where you are doing a lot of testing as part of the Kubernetes way of execution. Right now, these two things are not being tied together in the open era, and everyone is trying to doing, these are the two distinct activities. So we are hoping to get those things attached. So any questions? Meanwhile, let me just show that. So the test is done. It's just downloading the S3 artifact. Then it will archive. Let's go here. See the results. So this is again bringing back the same reporting what we use, and it is technology agnostic as long as you are able to use the specific execution of the programming. So here, if you see that in the container, how we are executing, we are making the container call with these options, and these are options which are actually being parameterized in the Argo workflow. And this is our test container image. If you have any question, just checking.
Thank you, Sumit. That's really interesting to see Argo workflows being used for different use cases. Does anybody have any questions they want to ask Sumit or Naveed about what they've seen today? If you're using Argo workflows or Argo events for something interesting or unusual, we do really enjoy seeing the demos of that. It's really interesting to find out what different people are doing with the technology. And it's, you know, those are the kind of demos are the most interesting things we have in these meetings. So we'd love to see more of those guys. Sumit, will you be able to share the slides with people afterwards?
Yes, I will be able to share the slides after this in our Slack.
Brilliant, brilliant. Okay, I'm now going to move on to a bit of a discussion about cost optimization. So at our company, like other organizations, you know, occasionally you have to go through a cost optimization exercise. And we had a little look about how people were operating and using Argo workflows, and we've come up with a few recommendations to share with you guys. And we also kind of want to hear about any kind of from the trenches experiences that you've had that you're able to share with us as well. So feel free to chip in at any point during this. So what I'm going to do is we're putting together a document to list some of these cost optimization ones, and they're kind of broadly split into two different categories. And one category is around optimizing the execution of your workflows, and another category is about the operation of Argo workflows itself. And the reason we split that into two categories is because typically the costs for executing workflows can fall on a different team or business unit or part of the organization to that of operating it, even though the two are obviously interrelated. And the biggest cost savings that can be had are around the actual execution of the workflows, Argo workflows itself, unless you have a very large number of workflows in your system, and we'll come back to that shortly. It doesn't actually have particularly high resource requirements. So the first tip is to limit your total number of workflows and pods, and there are 3 settings you can use in this on each workflow to do that. The first one is active deadline. It's actually active deadline seconds. This is the maximum amount of time a workflow is allowed to execute. And you can use this to kind of make sure that any workflow doesn't run away with a maximum time. The second one is the TTL strategy, and that determines when your workflow is deleted. Now, I think we broadly recommend everybody sets the TTL strategy to some kind of value, and you can determine whether or not your workflow is deleted after a specific number of hours, days, or weeks. This is 2 kind of use cases. One is to make sure that if you've got a workflow that contains sensitive customer data that they always get deleted within a specific amount of time. And also when you delete the workflow, it will also additionally delete any attached pods to it. So you can ensure that any resources related to that workflow are successfully cleaned up. That's why we recommend doing that. And the third setting you can use is a thing called pod GC strategy, and there are several potential options for this. One is on pod completion. You can also have one on workflow completion, and you've got variations such as on workflow failure, on workflow success, on pod failure, and on pod success. And the reason you want to do this is that even though when a pod is complete, it uses less resources, it's not completely cleaned up. There is a downside to each of these settings. The downside is that if your workflow or pod has failed, then deleting them will obviously potentially remove some of the useful information that you might want to have around failure. If you're like us, you actually probably archive the logs and all your artifacts automatically, and actually you can actually delete them on completion, but what you would want to do with that can vary. Now, this is a nice one to kind of combine using this feature called default workflow specification, which is a relatively new feature. And default workflow specification is a way in your config map here to set up a set of defaults that are used. And those defaults are merged in, like a mail merge into your workflow before it's executed. So these are defaults rather than overrides. And that means you can, in your workflow specification, specify different things. So for example, you could use a default pod GC strategy. But you may have some workflows where you don't want to use that default. You might want to use a specific one, and you can just change those in your specification. Now, these settings only apply proactively, not retroactively. But if you want to go and find out which workflows have been running your cluster haven't been cleaned up, then you can, because Argo workflows are just a normal Kubernetes resource, then you can run this resource to sort by creation timestamp, and you can find all workflows and manually delete them. So that's a tip for people executing workflows. Here's a couple of tips for people running a large number of workflow instances. So we run 107 installations of Argo workflows at Intuit, and it goes up and down. It's gone down because we've deleted some clusters recently. It was 111, so that's 107. You can use resource quotas, and you can use limit ranges to set the default memory of your Argo workflow installation. Now, the Argo server is stateless, so you can always set that to be the same value regardless of how many workflows you have. But the workflow controller uses a thing called an informer, and the memory usage of the informer grows with the number of workflows. So the best way to reduce the memory requirements of the workflow controller is actually to reduce the total number of complete and incomplete workflows that you have, and that will obviously address your cost beforehand. And then once you've got that down to a nice level, you can put in place limits to control that. Does anybody have questions about these two strategies before I move on to some of the more kind of niche strategies? Okay, that's silence, that's fine. Another, oh, go on, Michael.
Oh, you got a couple in chat.
Oh, I have a couple in chat. Let me open up the chat so I can read those. So I got a question from Evan. If I use persistence for jobs, how does TTL and pod GC apply? Okay, so can you clarify what you mean by persistence for jobs, please?
Like I use the Postgres node offload, I believe is what it's called. Mm-hmm. New to Argo, so. Mm-hmm. So my understanding is you have a garbage collector that runs, and that will put my job, my workflow into Postgres. Mm-hmm. Do these settings for TTL and pod GC, like how do those interact with the Postgres, the persistence part? Like when I set TTL, does that mean the job lives on the cluster and not in the database until that TTL time is met?
So I'll just address pod GC first because that's easy. That works as usual. That's not impacted at all by your persistence setup. For people not using persistence, there are two things you can do with persistence. One is to archive workflows, and one is to offload large workflows. And I'll just talk briefly about the offloading feature because I think it's important to go into some of the details there. The offloading actually only occurs under specific circumstances. So Argo Workflows prefers to store your workflow specification in the etcd database. However, the etcd database has a 1 megabyte limit to the size of the data you can store in there. So what happens is if it becomes large, what it attempts to do is compress a specific part of the specification, a part called the node status, which is under the status field /nodes. And the first thing it'll do is attempt to compress that and keep that data on etcd, because we know that's faster and more reliable than using a database for these things. It removes kind of edge cases where you lose your database connection, so your workflow fails. It's only when it can't compress, when it's too large and it can't compress it, then it offloads it into the database. So I'll save it in the database. Now that's actually quite a non-trivial piece of code to do there. That has to basically keep the database in sync with etcd and ensure the data that's stored there is correct. And the way that it does this is that it uses a hash of those nodes to allow it to actually store multiple records in the database. Now the way that data is TTL'd is it's deleted, only the most recent version is kept, plus anything that's happened in the last 5 minutes, because we need to be able to support a watch on each workflow, and a watch, excepd actually stores multiple versions of your specification in it. So we actually also therefore need to store multiple versions as well. And that TTL still applies to it, but there are two TTLs there. One is to delete the older data for 5 minutes, and the other one is to TTL those workflows. So in a short answer, that still happens. However, if you're using persistence to save your workflows into the workflow archive, that has a completely different set of garbage collection settings. Specifically, you can set a TTL for the archive, so your data is deleted. But that wouldn't be a short TTL. I mean, your TTL for a workflow might be 8 hours, whereas your TTL for the archive might be 180 days, for example. Evan, does that answer your question? I'm sure it's a very long answer.
No, so I actually we have a homebrew system that does pretty much this, and I have 40,000 artifacts right now in etcd, so I'm dealing with this right now as etcd is completely slowed down and everything on this homebrew system. Mm-hmm. So I'm just trying to make the parallel between this and Argo, and just ensure that the Argo artifacts get pushed into Postgres as soon as possible, as my DAGs are over 2,000-3,000 nodes wide.
Yeah, that would be a good thing to do, is have the persistence enabled, have that TTL set, jobs are on completion, and save them into the workflow archive so that the workflow control doesn't have to manage that large amount of data. And certainly for the use case of 1,000, 10,000 plus workflows, that's the right solution.
Awesome. Well, thank you for the answer.
So there's a question from Michael Crenshaw. Is there a way to set active deadline seconds at the step level? We have workflows with durations that vary with parallelism, but steps with reasonably predictable runtime. I don't know the answer to that question. Jesse or Bala, do you guys know if we can do that on a step level?
I think we can set it in the template level, not in the step level. You can set it in the workflow level or template level.
I think the short answer might be no in that case.
Cool, thanks.
I wonder if there's, I don't know, again, this might be a question for Jesse, if there's a built-in Kubernetes feature that you can leverage. I don't know. Okay.
For pod deletion?
Yes, for deleting a pod that runs too long.
No, not that I'm aware. I think the pods, will remain until, I mean, they get deleted, like, for example, when nodes disappear, but there's nothing that I think that just deletes pods without reason.
Okay. I'm just going to move on. Talk a little bit about executor resource requests. So we mentioned that you can configure them for the workflow controller config map. You can also set up the executor resources if you want to limit the amount of resources they can do. Again, this is one of those things that will scale with it. There is one downside to this. If you've got large artifacts in your system, which I'm sure many of you do, then you need to have more memory to be able to exfiltrate those artifacts from your executor. We also have the ability to set the pod resource requests. And there's a new feature that came in, I think 2.6, which will give you a summary of how much resources your pod uses. And the way that that's calculated is determined by the amount of CPU and memory requests you asked for multiplied by the resource duration, as in how long that pod exists for. So, you know, a pod that requests 4 GB of memory that runs for 1 minute, you know, is using kind of much total memory as a pod that requests 1 GB but runs for 4 minutes. So if you can, the less time your pods run, that's another way to reduce your costs as well. And you can see that in the user interface. I think that's going to be turned on by default in version 2.9, which will be at the end of June. The second to final, sorry, is to use a node selector to use cheaper incidences. So if you have some cheaper spot instances, you can set the node selector on your specification for that. And I'll just find an example. Oh, we don't have an example there, unfortunately. And that just allows you to choose a particular node to run on. And if that's a cheaper node, that's one way to do this. And I think we have just one other one. If you've got a workflow that has a large number of artifacts and it's copying it to and from storage, you might want to consider using a volume claim template. That allows you to basically mount a volume to your container for each step, and then you can read and write from that particular volume between different steps without having to save that artifact out to storage and then read it back in afterwards. And that might be quite good, for example, if you're running, this comes from a CI example. So you can create a volume that acts as a workspace or a working directory, and that's shared between all steps in your workflow. And at the end of the workflow, you can then upload those, you can zip those artifacts up and upload them at the end. Okay, so there's some recommendations, some tips, things for you to try out there. If you've got some ones you've done yourself or some experience that you want to share with us, we'd love to hear about that. You can drop us a message, or you can discuss it now if you'd like. Okay, is there any other topics that people would like to discuss during this meeting?
I asked in the channel, I'm curious about what pod workers and workflow workers does in the workflow controller.
You're referring to the two settings? Yeah,
the two flags for the CLI when it initializes.
Okay, so those, we've increased the default to those recently to 32. The workflow workers allows multiple parallel workflows to be executed. So if you're running a lot of workflows, then you should increase that particular setting. The pod workers is the same, but for pods. So every time a pod that's part of your workflow changes, you know, starts or stops or is successful or unsuccessful, it's dealt with by a pod worker. So if you have large workflows with many pods in them, then you can increase that setting to get more throughput. Both of those will require you to increase your the amount of memory you give to the workflow controller to support that. So that's how you can scale up vertically.
Do you have any guidance for sensible numbers there, or should I just stick with the defaults?
I would run with the defaults unless you have any particular issues.
Cool, thanks.
Okay, great. Well, thank you all for coming today. If you've got, we'll be sharing this video on YouTube. So we'll drop that video into Slack for anybody who wants to review that. And also I'll ask Sumit and Derek to share their slides, and I'll add those to the meeting documentation if you want to have a look at those again. Okay, thank you very much for joining us, and we'll see you again in 1 month's time. Bye-bye.
Thank you, guys.